Good morning, kids. In math today, we are going to be focused on multiples of 3 and dividing by 3 in your work. We're also going to be doing a little bit of problem-solving strategies and modeling the tape diagram strategy using Kami. Okay, so if you do not have your green workbook with you, pause the video right now and go get it, because we are going to be you're going to be doing this work with me as I am modeling it for you. And then your assignment today will be to go into the math folder, and you've got the homework for lesson 13 that goes with this. Now, what I'm asking you to do is spend 15 minutes on the homework. Okay, so I don't want you overworked. I do not want you spending hours or even any more time than 15 minutes. What I'm asking you to do is work hard on it for 15 minutes and then submit the amount of work that you were able to complete in 15 minutes. Okay, so for this lesson, we are looking at multiples of 3, and it is time for you to start committing your multiplication and division facts to memory, and we'll start slow, and we have all year to do this, but it is in fact an Indiana standard and a national standard for third graders to know the basic multiplication and division facts. So starting with threes, they're basically doing a count by here. So they've got 1 3 is 3, 2 threes is 6, 3 threes is 9, 4 threes will be 12. Okay, and we're just counting up 3, 6, 9, 12, 15, 18, 21, 24, 27, and then 10 times 3 is 30. So the tens facts are kind of an anchor, and if you haven't been hearing about the power and magic of the number 10 in our number system, you'll start hearing it from me a lot because our number system is a base 10 system, and we think with our friend 10 all the time. So tens facts are pretty straightforward. Whatever you're multiplying 10 by, you just stick a 0 onto the end of it. So see, I'm multiplying 10 by 3. I just stick a 0 on that 3 and I get 30. And then they ask you to do the related facts down below. So they start with the product. Remember, in multiplication, you have factor times factor equals product. And then that product is the whole that you start with in division. So the total number of items that you're dividing is the same as the product when you're multiplying. So remember, the parts of a division problem are the same as the parts of a multiplication problem. They're just in a different order. So you've got, in division, you've got a total number of items. You've got either the groups or the size of the group, and whichever one you don't have, you're solving for as the quotient. Okay, I know that's a lot of words, but math is a very vocabulary heavy subject, and learning the words and using the words is an important part of becoming a solid mathematician, a capable mathematician, and all of you have the ability to do this. So looking at this, we've got 1 times 3 is 3. So 3 divided by 3, I'm going to put my trusty text box here, is 1. What you'll notice is the numbers in this section, whatever numbers you have in the top part, you will also have in the bottom part. They're fact families. If you have a number down here that's different from a number up here, you haven't been doing it correctly. So part of understanding this is realizing that there are related multiplication facts to division facts, and they have the same exact numbers in them. It just, the order is what changes. So 2 threes is 6. So if I have 6 things divided into 3, or groups of 3 or 3 groups, I end up with 2. Notice that I have the 2 here and the 2 here. So they're going to switch it up on you here. So 3 times 3 gives me a total of 9. Well, in division, I start with the total, so I'm starting with that 9. 9 divided by 3 is 3. So 4 groups of 3 here brings me to my next multiple of 3, which is 12, and then that's my total to be divided. So I do 12 divided by 3. So in each of these examples, you're looking for a product, and the same product that you come up with ends up being the number that you're dividing into groups. So they're asking you for the starting number in each one of these. So pause the video and work through the rest of these here. I'll do one more for you. We've got 15. So basically you're doing a count by 15, 15. You're counting up by threes. 3, 6, 9, 12, 15. The numbers are in order. So they're giving you 6 times 3, 7 times 3, 8 times 3. It's basically a count by that's got the equations with it. Okay, moving forward. I've only got 15 minutes, so I got to buzz through this, and that's a good thing. I don't want to talk forever. I want you to be doing the work here. I'm going to do the drawing here, the drawing tool. Mr. Lawton picks tomatoes from his garden. Okay, we understand that. We can visualize that. He divides the tomatoes into bags of 3. Okay, we can visualize that. So each bag has 3 tomatoes in it. Circle to show how many bags he packs. Okay, I like to use a different color when I do this so it stands out. So here's 3. Here is 3. We got a 3 here. And my last bag of 3 tomatoes here. So I've got 4 bags of 3 tomatoes. Okay, if I counted them, I would be able to tell the total, or I can practice my skip counting, count by threes. 3, 6, 9, 12. Okay, now it's asking me to draw and label a tape diagram to represent the problem. I'm going to do a shape here. I'm going to insert a rectangle because the tape diagram is in the shape of a rectangle. Okay, and so I know that each unit, that there are 4 units, okay, 4 equal-sized units, and in each unit there are 3 things. So what I'm going to do is I'm going to draw, 4 is an even number, so I can divide my tape directly in half, and then I can divide each half in half to get my 4 bags. So each of these units represents 1 bag, and inside each section, I'm going to put the number of tomatoes, 3, 3, 3, 3. Okay, so this section here, I'm going to go back to my drawing. This section here would represent 1, and actually what I'd put here is a text box. A text box would be better. I want to go ahead and just insert that text box. 1, I'm going to move it over here so I can see, you know, this is kind of challenging work, but we need to get used to it. It's just another tool for us to be able to demonstrate that we're learning the things that we're supposed to be learning. So 1 bag is going to be 3, and so we've got 4 bags here. So we'll make another drawing here that shows what the total is. So that is the total. And the total is 12 tomatoes, or I could just write total if I wanted to, 12 tomatoes. And when I go over here to my equation, I've got 12 total items divided into bags of 3, which gives me 4 bags. Mr. Lawton packs 4 bags. 4 bags. Okay. I'm having trouble highlighting it. I don't know why it won't light up. Oh, I was on the wrong text, the wrong tool somehow. Okay, so he packs 4 bags of tomatoes. All right, so click out and moving on. Camille buys a sheet of stamps that measures 15 centimeters long. Just to remind you, you are supposed to be doing this with me and thinking about it as we go. I'm at the 9-minute mark. I've only got 15 minutes, so I'm going to buzz through. Camille buys a sheet of stamps that measures 15 centimeters long. Each stamp is 3 centimeters long. How many stamps does Camille buy? Draw and label a tape diagram to solve. Okay, so you see we're working with the 3 again, multiples of 3, and they give us a total. Okay, Camille buys a sheet of stamps that measures 15 centimeters long. That's the total. So my tape diagram that they're asking me to do, where it says draw and label a tape diagram to solve, that I need to start with the total since they give me the total. I'm going to draw my rectangle here, like this. And I know that Each stamp is 3 centimeters long. Okay, well, I'm going to do just a quick count by here to see how many threes it takes to get to 15 centimeters. So if I've got a stamp that's 3 and I put another stamp next to it, that gives me 6. And then I'm just using my fingers to count and talk out loud here. So I've got 2 threes to get to 6, 3 threes to get to 9, 4 threes to get to 12, and 5 threes to get to 15. So I've got to break up my tape diagram into fives, and 5 is not an even number, so I'm not going to break it in the middle there. I'm actually going to delete what I just did there. I'm going to use the drawing tool. So I'm going to cut this into 5 sections. Okay, they're supposed to be even, but it's not even. So notice that when I make 5 sections in the tape diagram, I use 4 dividing lines. So I've got 1 section, 2, 3, 4, 5 sections, but 4 lines that I drew to cut it into 5 sections. And I know that each section is 3 centimeters. So I'm going to do 3 and 3 and 3. Whoops. I don't know why that keeps happening. There we go. 3. Do another one. 3. And another one at 3. And I can see, I can go ahead and finish this thing up. My tape diagram is 15 total centimeters. So back to the text box here. 15 centimeters is my total. Each stamp is 3 centimeters long. How many stamps? Well, each one of these right here represents 1 stamp. So if I just count the units, 1, 2, 3, 4, 5, I can see Camille buys 5 stamps. Another way I could write this is 15 divided into 3 centimeters each gives me 5 groups of 3 centimeters. Okay? It's not asking you to do this equation, but if you are the kind of person who thinks in equations first, I happen to be one of these people, it helps me to see the numbers and how the numbers work together. All right, so we're at the 1240 mark, and I've got 3 problems left. They ask you on number 4 to do to just solve the problem. They don't ask you to do a tape diagram, and they don't ask you to do a tape diagram on the last one either. So we're just thinking about how are we going to do this. 30 third graders go on a field trip. Okay, 30. I'm already thinking about my relationship to the number 3. I know that we're working with the number 3. And when we were talking back here, the 30, we already decided that it takes 10 threes to make 30. So 30 third graders go on a field trip. They are equally divided into 3 vans. Okay, how many students are in each van? Well, I'm going to do a little count by here. I'm going to do shapes, and I'm going to make my vans rectangles. So here's 1 van, here's 2 vans, and here is 3 vans. And if I wanted to, I could do like 1 stick or dot for each person, but I can start thinking about it in terms of numbers. I can do, okay, I know that there's going to be 10 in this van, and there's going to be 10 in this van, and to get me to 30, I need 3 10s. So there's going to be another 10 here. And so when I do 30, I start with 30 total students. I divide by 3 vans. That's the number of groups. I end up with 10 items per group. In this case, the items per group is the number of students. Okay, and so I got to answer. There are 10 students in each van. All right, I'm not going to be able to get this last problem in my 15 minutes, so I just want to review with you. You are going to head to the math folder. You're going to open up the the Wednesday homework. You're going to open it with Cami. You're going to do as much as you can in 15 minutes and submit it. Okay? Do your best. Good luck. Don't forget to come to our meetings with questions.